In real-world scenarios, the data for your analysis does not come in perfect shape. Often it needs to be joined together from multiple tables, and when that is done, you find out that entries are missing, have inconsistent formats, duplicates, or simple typos. So the task of data cleansing is one of the important steps during data preparation. Therefore, we've created a whole section dedicated to this pre-processing step in RapidMiner Turbo Prep. We've preloaded the Titanic dataset from RapidMiner Studio's Samples folder. The example set has 1,309 rows and 12 columns or attributes. Some of them, like name or ticket number, are similar to a unique identifier, as indicated. Others are unstructured or have missing entries. When you open a cleanse session, then most actions are deactivated because we've not selected a column yet. As I select the lifeboat column, you can see that Replace Missing, Dummy Encoding, and Remove Duplicates are being activated. The many missing entries are not because they've not been populated, but because most of the passengers did unfortunately not reach a lifeboat. Therefore, I can replace the missing entries with relevant information and use, for example, the specific value none. The other active options are Dummy Encoding and Remove Duplicates. For Remove Duplicates, it is important to know that it only checks for duplicates in the data that you have selected. So if I apply it here, you see that only a few rows are remaining because each distinct value in this column is now shown only once. If you want to remove entries which are similar in some or all attributes, then select the relevant columns or press Ctrl-A or Command-A to mark all, and then use the Remove Duplicates operation. Okay, I'll go back and highlight only my lifeboat column. It is currently formatted as a categorical column because it contains numbers and text. Some models can't handle text, so if we would want to turn this into a numeric column, we could use dummy encoding. Dummy encoding creates a column for each distinct value, and then it assigns ones to each row where that value occurs. So for a large number of distinct values in a column, it will increase the width of your table substantially. The column details can help to assess this. For our lifeboat attribute, it is 28 distinct values. Make sure to weigh cost and benefit when using dummy encoding, as it may have a negative impact on the speed with which your models are being calculated, but it can also help you to yield useful information. Speaking of the number of columns, the generic cleansing operations, remove correlated and remove low quality, are available to tackle that exact problem. When you're creating a model and you have two highly correlated columns, you won't gain any extra boost for your model if you take both into consideration, but you will have a longer calculation time if you do. So getting rid of highly correlated columns, as well as those with many missing, is a good best practice. The Remove Correlated option is very simple to execute, as you only define the correlation threshold before you run it. Note that the input is interpreted as an absolute value, so it applies to positive and negative correlations alike. Remove Low Quality is configured through a combination of quality measure thresholds. You can use the default, or in case you want to fine-tune this procedure, then you can find more details here. Okay, so far we've looked at cleansing categorical variables individually and at reducing the number of columns with a more general approach. The only thing left is to look at numeric attributes. I'll select age here, and you can see that the applicable operations are becoming active. Of course, we can replace missing, which in case of age could be achieved by simply filling in the average age. In cases where you want to change a numeric variable into a category, you can use the discretization to do a binning with bins of equal size or range. If you have multiple numeric attributes with values of different scale and variability, like for example, age and ticket price, then you can normalize each or all of them. The normalization will be useful in such cases to balance your numeric values. In cases where you have many numeric attributes, a principal component analysis might be helpful to apply. The PCA result will be several numerical columns, which are linear combinations of the original data, while keeping the variance. Okay, this was a brief review of all the individual procedures for numerical values. We won't use any on our data, so we can commit our cleansing adjustments. Now let's see what auto cleanse does. If we open the help, then we can see the steps which are applied. We've just discussed and applied some of the steps shown, and so instead of applying all those manually, you could use auto cleansing instead. It will apply all of them for you with a structured walkthrough, which leads to the desired results very quickly. We will go through it now, but first, please take note of the number of rows and columns so we can see the impact. In the first step, we're asked to select a target column. Selecting one means that this column is excluded from the cleansing. This is important because you would want to preserve it even in cases of high correlation with any of the other variables. Rows with missing values in the target column should also be excluded from cleansing since you might want to apply your model to those later. In this next step, we get a preview of which columns will be removed. Name and ticket ID are excluded because with all their unique data, they're not helpful to generate a generalized model, and neither is cabin due to too many missing entries. As you can see, our dummy-coded lifeboat column, which represents the value none, is being kept as it contains valuable information, in contrast to the others which are mostly 0 and therefore very stable. The type conversion step is up next. Keep in mind here that this is always applied to all columns. If you want to do it for a subset, then going through multiple cleansing cycles, like we did here, is the best approach. In doubt, just leave things as they are. Now, this last configuration screen deals with numeric columns and so only appears if you have any in your dataset. You can choose to apply a PCA or normalize, or even do both. I've explained the general principles of each operation before, so I'm just finishing this dialog walkthrough before I commit the cleansing. We have now fewer than 10 columns left and prepared them to be used for further processing or as input for AutoModel. I can jump into it right here, and as I go through the dialog quickly, you can see that we're warned about this lifeboat variable. This type of warning is in fact important and should not be ignored when building models, unlike we're doing here. When you look at the results, you see extremely high accuracies, which are of course unrealistic. These are due to the highly correlated lifeboat column. The information who did or didn't reach a lifeboat is an almost perfect proxy to predict survival and would not have been suitable for use in our scenario, as indicated by AutoModel before. To learn more on this and other details on how to use AutoModel, please check out our other tutorials. Thank you very much for watching.